Good morning, good afternoon, good evening, whatever time you're watching this. We're now going to cover vitamins, water, electrolytes, and minerals. We've got a lot to do, so maybe you should get yourself some popcorn. Yep, the dietitian is recommending some popcorn. The reality is I'll be breaking these videos up into 15 to 20 minute segments. I have no idea how many there'll be, so I should get started. I talked in the videos that you should watch before you get to this. Fat-soluble vitamins can be toxic because they're stored in the fatty tissue and it takes longer for fat to break down. But the reality is that some of the water-soluble vitamins can also be toxic in large amounts. And these large amounts usually occur from taking supplements. They don't occur from getting your nutrients from food sources. I'm not going to test you on these, but I thought it was important to know. So when you get your supplements that say contains 1,000% of the recommendations of these nutrients, that's just because they're cheap, but I wouldn't recommend getting your nutrients from supplements. I'd rather see you get them from food. In the videos, I covered fat-soluble vitamins and water-soluble vitamins, looked at food sources, deficiencies, toxicities, some wonderful pictures. I did forget to tell you, and I feel it important that you know, vitamin A toxicity from beta-carotene is rare because what happens is you turn orange from getting a condition called beta-carotenemia. But if you ever consume polar bear liver, you could die. Okay, it's never on the menu because nobody orders it because it's not something that's out there to eat, but it was something I learned in graduate school, and it's one of those things that has never left my head. So I'm telling you, if you eat polar bear liver, you'll develop a toxicity of the animal form of vitamin A. The other concern for toxicities from vitamin A are in vitamin supplements. When you have more than 50% of the amount of vitamin A coming from retinol, what you want is most of the vitamin A to be coming from beta-carotene. With respect to what you would need to know for exam purposes, if you look at the bottom of this slide is the Vitamin Game Show PowerPoint. That's what you need to know for exam purposes. This is what it looks like. It's posted on Blackboard, and that's all I'm going to say about it. So have a look at it. Since we aren't going to be able to play with it in class, you'll have to play with it on your own. If you have any questions, as always, please see me. What I didn't talk about in the video that I want to cover briefly, because I have a wonderful short video you can look at that will also reinforce what I'm talking about, are antioxidants. There's a lot of words out there about antioxidants as superfoods, as I don't know what else, because the word superfood just forms a cloud in my brain and doesn't let anything else through. But when we're talking about antioxidants, we're mainly looking at what are called free radicals, electrons, something called oxidative stress, and antioxidants. Free radicals are highly unstable and reactive atoms or molecules that have one or more unpaired electrons in the outermost orbital. The video will show you a picture of this. If you go back into the gray matter when you first had chemistry, you learned atoms and molecules are stable when the electrons are paired. But sometimes things happen in the body that cause the electrons to move around, and if there's one or more unpaired electrons in the outermost orbital, that causes instability, and that creates free radicals. Electrons are the negatively charged particles that are found in these orbitals. We have antioxidant enzymes and dietary antioxidants. Oxidation refers to what happens to the molecule when an electron is being removed from the outermost orbital. When a free radical is formed, it's said to be oxidized. Antioxidants help prevent oxidation because they donate an electron from themselves to that compound that is a free radical. It stabilizes that compound, and the antioxidant also remains stable. Dietary antioxidants come from beta-carotene in the vitamin A family, vitamin C, vitamin E, selenium, certain phytochemicals or plant chemicals, and food sources of these are, of course, the fruits and vegetables, also legumes, grains, whole grains, unsaturated oils, nuts, and seeds. Again, free radicals are what we refer to these molecules that have lost an electron in their outermost orbital, and they can be formed by sunlight, smoking, and pollution. These I'll show you in the next slide. What I also want to mention, though, is that free radicals are also a part of our immune system. We need to have free radicals in our body because they're part of our immune response, but it's about balance. When we have an excess of free radicals in relation to the antioxidants that we have in our body, that's said to lead to oxidative stress. This is a condition in which the production of free radicals exceeds the body's ability to defend itself. Please have a look at this video. I posted it in the class videos, the new ones that I've made that discusses what free radicals are and also how antioxidants help to neutralize free radicals. On the left are some of the conditions that can lead to the formation of free radicals. For example, the ultraviolet rays from the sun can penetrate the nucleus of the cell, causing alterations in the DNA, leading to production of proteins that are mutated and can cause cancer. The same with cigarettes and environmental pollution. There are processes in the body that also lead to the formation of free radicals. These may refer to the ones that are part of our immune response. The antioxidant theory, keep in mind, theory of disease prevention is that when we have a balance of free radicals and antioxidants, our body is in homeostasis. But when we move to B and there's an addition of free radicals, for example, exposure to excess sunlight, smoking cigarettes, being exposed to a lot of environmental pollution, then you are out of balance, leading to oxidative stress. The hypothesis is that oxidative stress can lead to the development of chronic illnesses. In C, if we increase the antioxidants, then the theory suggests that balance can be restored. This is the antioxidant theory of disease prevention. We should get our oxidants through food. Of course we should. I wouldn't be teaching this course if I thought you should be taking a pill. Foods contain antioxidants and other valuable nutrients. When you take a supplement, for example, vitamin C, all you're getting is vitamin C. When you eat an orange, you're getting vitamin C, you're getting potassium, bioflavonoids, calories, water. In other words, the antioxidant actions of fruits and vegetables are greater than their nutrients alone. So please get your antioxidants along with your other nutrients from foods, not pills. What's the difference between a physiological level and a pharmacologic dose of a vitamin? Physiological refers to the amount that our body can handle, are physiologically capable of dealing with. And that's what we get from fruits and vegetables. You really can't overdose when you eat fruits and vegetables, when you eat food. But it's when you get mega doses of nutrients from pills that your body isn't able to handle it. And we refer to this as a pharmacologic dose, pharmacy, drugs. In this case, what happens is your body is no longer looking at this nutrient as something that can provide, that's considered essential, but it's looking at it as a drug, and it must be processed differently. As a registered dietitian, I would never recommend a pharmacologic dose of a nutrient. I don't have prescription writing privileges, and a pharmacologic dose is a prescription level dose. Physiological dose is what you get from food. If you have a nutrient deficiency, then your doctor should be prescribing you what you need, not a registered dietitian. Please know the difference between physiological and pharmacological doses of a nutrient. The videos on this topic, to summarize what we covered in this topic, including the previously recorded videos, toxicities and deficiencies take longer to develop for fat-soluble vitamins compared to water-soluble vitamins. But as I showed you at the beginning of this video, you can develop toxicities from too much water-soluble vitamins. They're not exempt. Fat-soluble vitamins are grouped by their solubility in oil. Water-soluble vitamins are grouped according to their solubility in water. Fat-soluble vitamins are hydrophobic. Water-soluble vitamins are hydrophilic. Vitamins have specific chemical forms and functions in the body, and there are recommendations for the essential fat-soluble and water-soluble vitamins. Deficiency, toxicity, signs, and symptoms are unique for each of these nutrients, as are their food sources. That's it for the vitamins. Now we'll look at water and minerals in the body. We'll look at water functions and the importance of water. We looked at it a little bit when we talked about fitness. We'll look at it some more because we can. Look at the different fluid compartments, intake needs and sources, output and losses. We'll talk about dehydration and intoxication or overhydration, and the electrolytes, sodium, potassium, and chloride. Minerals are inorganic elements that are found naturally in the earth. We talked about vitamins as being organic compounds, meaning they contain a number of different elements. Minerals are inorganic individual elements. They're divided into major and trace. Major are found in greater than 5 grams in the proverbial reference body, and trace are less than 5 grams in the reference body. It also means we have more of the major minerals and less of the trace minerals in our body. It has nothing to do with the importance. It just has to do with the amounts that are found inside our body. And since the major minerals are found in greater amounts, we require larger amounts of them in our diet. Major minerals include the electrolytes sodium, potassium, and chloride. Major minerals in the bone include calcium, phosphorus, and magnesium. And in our lean body mass or protein, sulfur is the major mineral. Trace minerals include iron, copper, iodine. You can look at these. The only one we're going to be covering is iron. We need them in milligram or microgram amounts depending on the nutrient and depending on whether they're major minerals or trace minerals. The amounts are also based on age, gender, and physiological condition. Are you growing? Are you an adolescent going through your growth spurt? Are you pregnant? Are you lactating? All of these can have an effect on how much your diet should provide. We'll talk about some of the essential minerals, and if you recall our definitions of essential, when you have inadequate or deficient intake over time, deficiency signs and symptoms will develop that should reverse once those nutrients are added back into the diet. Should, assuming that it hasn't gone too far. And also when you consume in excess, UL stands for upper limit, toxicity signs and symptoms may develop over time. Some foods or food groups provide a good source of certain minerals and not others. The example I like to give is milk. Milk is an excellent source of calcium, but it is lousy for iron. One of my first jobs was as a WIC dietitian in Pennsylvania, Women, Infant, and Children Supplemental Feeding Program. We would evaluate families on whether or not we could provide them with vouchers for food based on their diet and financial situation. Many times children would be iron deficient. When I would talk to the parent, I would find out that they'd been giving their children a lot of milk because, well, milk's a good source of protein and it's also a good source of calcium, but these kids would fill up on the milk and not be hungry for foods that would provide them with the iron. In general, as always, eat a wide variety of foods from each of the food groups and drink fluids to meet your mineral and water needs. Water, we know what water is. It's an inorganic compound composed of 2 hydrogen atoms and 1 oxygen atom. Dihydrogen monoxide, one of my favorite chemical forms to talk about. In our body, water provides a medium for chemical reactions. It participates in energy formation. All reactions in the body involve enzymes, energy, and water. Water regulates nutrient and waste products. Our blood is mostly water, and it's responsible for taking nutrients to the cells and removing waste products from the cells. It helps to regulate body temperature. It acts as a lubricant and cushion and helps to maintain fluid volume. We'll talk more in a bit about the different fluid compartments, but for now, let me just introduce you to what's the different compartments found inside and outside the cell. Within the cell, we refer to this as the intracellular compartment, of which potassium is the major mineral. And since it's in a charged form, it's referred to the major intracellular electrolyte. Outside the cell, or extracellular compartment, the major electrolytes are sodium and chloride. While there aren't specific recommendations for fluid, and my general recommendation is to, with barring any specific health situation, to drink when you're thirsty. Here's a guideline that if you wish to use it, it's fine. In a few minutes, we'll talk about how a lot of the foods that we consume, fruits, vegetables, even ice cream, contain a lot of water. There's no upper limit for water, but certainly you can consume too much water. Those of you that go to class with your gallon of water, if you sat in that one sitting and drank that water, you would exceed your upper limit in that period of time, and you would have some problems with your kidneys. Some of these levels may not be optimal for folks. Keep in mind that physical activity and heat stress can affect how much water you need. No, you don't need to remember these numbers either. From this picture, you're supposed to understand, though, over time, intake from food, from liquids, and the amount produced when you have reactions going on in the body, though that's what metabolism refers to, should be equal to the amount that we lose, not just through urine, but through feces. When we exhale CO2 and water, and through our skin. Over time, fluid intake and fluid losses should be equal. Optimal fluid intake and output helps us to have healthy skin. It helps maintain body weight and urine volume. If you're drinking a lot of water, your body doesn't need, what the body doesn't need, it will excrete. So the urine will be dilute and produced at a faster rate. This is when your urine is lighter in color. If you're not drinking enough fluid, your urine will be more concentrated and it will be produced at a slower rate. I asked a renal kidney doctor once, because students want to know, what color is your urine supposed to be? And she said, excluding any type of kidney condition, whatever color it is. If you're drinking a lot of water, then it'll be lighter in color because your body is excreting what it doesn't need. If you're not drinking enough fluid or not getting enough fluid, your body will hold on to that water and you will produce less urine and it will be darker in color. So the color of your urine is not an indication of your health unless you've been sick, right? Let's put that asterisk there. With insufficient intake and excretion, though, dehydration can occur. And this is over time. Some of the adverse effects of dehydration: when your body needs more fluid than it's getting, a 1 to 2% body loss. So the effects of dehydration would include thirst, fatigue, weakness, loss of appetite. But as that weight loss continues, when your dehydration is prolonged, the symptoms, well, can be fatal. How do you become dehydrated? All right, please don't look at this slide as a how-to. I'm not telling you how to be dehydrated, but I am saying that caffeine can cause dehydration, not caffeinated beverages, because your beverages are mostly water, but caffeine powder, caffeine itself is a diuretic. It can cause increased urination. But remember, most of your coffee, most of your tea is water. Alcohol will cause you to become dehydrated, and symptoms of hangover are symptoms of dehydration. Diuretic medications, diuresis means increased urination, and folks who take these kinds of medications, for example, some blood pressure medications or diuretics, these folks can become dehydrated. Sweating, fluid loss, when you don't replace the fluid that you're losing from sweat, you can result in dehydration, and heat exposure. I have down here this asterisk, unless energy beverages. There are some energy beverages out there that are really loaded with caffeine. So I'm just kind of covering myself saying these can cause dehydration. Why you need to drink those beverages, I'm not going to guess. But I did throw this in here because people like to drink their coffee, provides them with caffeine, and I used to know how much caffeine was in the average cup of coffee, but now I have to look it up just like everybody else. McDonald's coffee has less caffeine per fluid ounce than Starbucks, and there's something out there called Death Wish coffee. If the maximum amount of caffeine that you're supposed to get in a day is 400 milligrams, an 8-ounce cup of this Death Wish coffee, well, you're exceeding that limit with 1 cup. So any of you out there ever try it? I'd like to hear how it worked for you. Chronic mild dehydration is linked to reduced physical, mental performance, and you become more thirsty. Your salivary glands produce less fluid. It also puts you at risk for urinary tract infections, kidney stones, constipation, these other conditions that are listed here. I generally don't worry about your demographic becoming dehydrated, but as we age, our thirst mechanism is less active. And for older folks who are taking medications, there may be interactions. It may depress their thirst mechanism, so they may not drink as much. Also, some folks who aren't very active or aren't very mobile, who sit all day for whatever reason, they fear becoming incontinent. So they may not drink the amount of fluid that they need because they don't want to wet themselves. This can lead to dehydration. Public service announcement. Have any of you ever bought this brand of water? Aquafina. I have this little yellow arrow pointing to what is going into this water. And it's not anything magical. It's just coming from your tap. Don't waste your money on bottled water. Please don't. The opposite of dehydration is water intoxication, also known as hyponatremia. Hypo meaning less than. Na is the chemical symbol for sodium in the blood. Low sodium levels in the blood. This occurs when a person replaces water but not electrolytes. It's a rare condition, although it shows up often after a marathon where folks have been sweating and drinking lots of water. Then they can develop this condition. It's associated, as I said, with low blood levels of sodium. CNS means central nervous system edema. Your lungs become congested, your muscles become weak. See, what happens is with exercise, with sweating, you're losing both water and electrolytes, water and sodium, and both of them need to be replaced. Do you need any fancy beverages? I talked about that in a previous lecture, that you don't need any fancy beverages. I still go with Nancy Clark's recommendation to have chocolate milk and French fries, but it's certainly important to drink water. The electrolyte replenishment beverages that are out there really don't replace enough electrolytes, which is why it's best to get those replacements from food.